Hello, and welcome to our presentation on detecting Alzheimer's disease. Throughout our project, we decided to work on 4 major steps which we'll outline in this presentation, the first of which was to identify the problem, which was Alzheimer's disease. The second step was to develop a solution, which was to identify different stages of Alzheimer's. The third step was to test a CNN model that could determine whether or not Alzheimer's disease was present. The fourth step was to implement this model into the real world with the use of a web app that could run it anywhere. The first step that we covered was to identify the problem, which will be discussed now.
So why are we eager to refine a better diagnostic process for Alzheimer's disease? First of all, being a neurodegenerative disease that results in memory loss and cognitive difficulties, Alzheimer's disease is currently the most common neurodegenerative disease worldwide. It is estimated that around 15 million people suffered from it. Besides, although there are medications to help with symptoms, currently there is no cure. Therefore, accelerating and refining the diagnosis can help save countless patients from irreversible brain deterioration.
Current approaches. One method that doctors use to help determine whether someone has Alzheimer's is reviewing the person's medical history, so they might ask about the person's overall health, diet, and prescriptions. Doctors also conduct cognitive tests, which assess certain cognitive skills like memory, attention, and problem solving. Another current approach to diagnosing Alzheimer's is lab tests. These include taking blood and urine samples, which can help rule out other health conditions. Many of these current approaches require repeated doctor's visits over time, but Alzheimer's should ideally be diagnosed as soon as possible. So the second step of our project was to develop a solution that would help address this issue.
Based on the results of Alzheimer's testing, the clinician must eventually come to an overall decision. Our goal is to assist clinicians in accurately diagnosing Alzheimer's. Our team developed a user-friendly web interface that detects whether a patient has Alzheimer's or not, and if so, what stage of dementia they're at by simply inputting an MRI brain scan. Early detection of Alzheimer's disease can help with proper treatment to prevent further brain tissue damage. With an accurate and efficient Alzheimer's detection method, we can not only help families financially prepare for taking care of someone with the disease, but we can also decrease the number of people with AD that go undiagnosed, as only 1 in 4 people with Alzheimer's are actually identified. To develop our Alzheimer's detection method, we use a dataset of MRI brain scans retrieved from Kaggle. There are 3 major stages in AD: very mild, mild, and moderate. Currently, detection of Alzheimer's disease is still not accurate until a patient reaches the moderate Alzheimer's stage. This dataset contains nearly 10,000 MRI images, split into 4 classes, 1 of patients without Alzheimer's disease, and 3 of each stage of the disease. We use these brain scans to help us train an accurate model to determine whether a patient has AD or not, and if they do, what stage they're at.
To classify the different stages of dementia with relation to Alzheimer's disease, our group decided to use a convolutional neural network, or CNN. But what exactly is a CNN? To understand what a CNN is, we can first define what a neural network is. A neural network is like a function. You give it an input, and it will do some processing, and it gives us back an output. So within that processing is a changing of weights or priorities. So for example, if I was to train a neural network to detect a cat or a dog, the network might prioritize the shape of the face over the color of the fur. What makes a CNN special is the convolution part. A convolution is an operation that uses a filter to clean up the input and removes the less important parts. So in our case, the CNN might find some details in the frontal lobe of a brain MRI, which allows it to differentiate between the different stages of dementia.
In our live presentation later today, we will elaborate more on the different CNN models we tried, and we will test our final model with some brain MRI images using our web app interface.